Hello and welcome to you all again. It has been really very long time since I uploaded the last video. But in this duration, the number of emails, the queries, the appreciation I received from all of you, it's really very motivating for me. I was actually engaged in some of the very important projects, so I did not get the time to upload the video. But now it's the time to resume our ongoing series, that is architectures. And we will start this session with one of the very well-known reactive architecture, that is Redux. And these are the topics that we will cover as an outline in this video, and you will start learning from the concept up to coding sample for this tremendous architecture. So let's start our first reactive architecture, that is Redux. Origin of the Redux architecture lies into a bug, and that bug was faced by the Facebook few years ago. And what was that bug? That bug was related to the unread messages count. So they wanted to display unread messages count on the multiple screens, but they found on the different screen that count was displaying as the different number. So to solve this particular issue, Facebook introduced Flux architecture, and Redux is completely inspired by this particular one. In the starting, it was implemented in the JavaScript only, but later on all the other languages also adopted the same. We will understand the different component and the structure and the communication between the different layers of the Redux in the component and the structure section of this particular video. But going forward from here, we will try to understand that in what kind of projects or in what kind of problems you should use Redux architecture. To understand the usage condition of this particular architecture, you need to understand two very important capabilities of Redux architecture. Number one, Redux is reactive architecture. And number two, it has the capability to maintain the single source of truth in your application or in your project. Now we will understand these 2 points one by one. Number one, Redux is the reactive architecture. So it has the capability to deal with the continuous stream of the data. And now I am giving you two very practical examples from the real world where this continuous stream of the data situation can come to you. Number one, stock applications. Number two, medical applications. So in stock application, there always come a situation where you need to plot a continuous stream of the data into some graphical representation or into some visual representation. And same situation can come to you into medical application also, where you need to plot a continuous stream of the data that is coming from some medical instrument into some visual format or into some graphical format. And these kind of instruments may be heart rate monitor or can be some other instruments also that is sending a continuous stream of the data to your application. Now second point is ability to maintain this single source of truth. Now you will come to the reason that why I told you that Facebook story in the starting. So in the Redux architecture, store is the only place from where the state of your application can change, or you can receive the new state only. And reducer is the place from where your state change can happen into the Redux architecture. We will jump into the details of these particular things when we will describe this particular architecture in the detailed way. But for now, it's very much important to understand these two capabilities of the Redux architecture, just to understand that in what kind of projects or in what kind of situations you must choose Redux as the architecture for your project. And now I hope you understand these 2 points very clearly, that when you should choose Redux as the final architecture.
This is basically the component and the structure diagram for the Redux architecture. With the help of this diagram, you would be able to understand all the major components and the control flow of the Redux architecture. So store, reducer, action and the view. These are the main components of the Redux architecture. Center to the Redux architecture is the store layer, and store is the place where all your application states lives. And store always works as the live snapshot for the state of your application. And whenever application need to have a new state, then this state will always come from the store. So this is the single source of the truth in the Redux architecture. To understand the control flow, we will start from the view layer. So whenever user take any interaction or whenever user do any interaction on the view layer, then corresponding to that interaction, view dispatches an action over the store. And once this action reaches to the store, then store asks to reducer layer to generate the new state. And once the new state is generated inside the reducer layer, then it reaches to the store. And here Vue is continuously observing to store for any kind of the state change. So reducer is the place where state change happens, and stored is the place from where Vue receives the updated state. And once Vue get any kind of notification that yes, store has given a new state, then it updated itself accordingly. So here you can see this is the place through which you can receive the single source of the truth for all the Vue layers. Reducer is the place that is responsible to make change in the state, and Vue continuously observe stored for any kind of state change. So this is the property through which Facebook was able to solve that bug that we discussed in the starting. So this is the structure of Redux architecture. After understanding the component of Redux architecture, now it's time to understand that how exactly you will convert those components of the Redux architecture into your code in your application or in your project. So at the very first, we will be having the state that will basically represented by with the help of classes or with the help of struct. And if your application is having a complex state, then it will be divided into the substate also. Store, you already know that this will be the place that will hold all your application states and will work as the single source of the truth in the Redux architecture for your application. Action will be the thing that will be responsible to initiate the change into the state with the help of state and the reducer whenever user will do any interaction on the Vue layer. And reducer is the place where that state change will actually happen, and or you can say that this will be the place only where your state can basically mutate. In your application, Vue and the Vue controller will work as a, or you can say will behave or will be implemented as the subscriber only in the Redux architecture. So they will continuously monitoring the store for any of the state change, and whenever any state change will occur, then according to that state change, they will update the UI layer. Thunk will be the new concept in the Redux architecture that you will learn here. Basically, Thunk is a kind of pattern that is used to write the async function. For now, it is sufficient to know about the Thunk, and once you will jump into the implementation, you will get all these layers or all these code components in the very detail, and you would be able to understand them very easily. So now it's the time to jump into the code sample. For the demonstration purpose, we are taking our old favorite and the simplest application, that is weather app. And the reason behind taking this simplest app for the demonstration purpose is we just want to keep you focused only on the learning of the implementation of the particular architecture rather than giving you the complexity of the particular app. So let's start learning the Redux architecture with the help of weather application. ReSwift and ReSwift Thunk are two new Cocoa pods that we are going to use in this particular sample, where ReSwift is basically a small framework that gives you an ability to implement Redux architecture in iOS application. And ReSwift Thunk will become more clear to you where exactly it is implemented in the application. We will discuss this thing in more detail. For now, you need to have a Cocoa pod file with these two pods added in that. I am assuming that you have already installed those two Cocoa pods, that is ReSwift and ReSwift Thunk, and now we will start understanding the implementation of the different classes in the Redux architecture. So the first class is state. So state in the Redux architecture is implemented with the help of struct, and that is given name as app state. So here our application is having majorly, or you can say our application state is having majorly three attributes. One is latitude, longitude. Those are the coordinates of our current location, and weather data, that is the response of the API that is coming against the current location given. So here one thing you need to understand is if your application is simple and the state of application can be defined with the help of limited number of the attributes, then you can have only one state in your application. Now there could be a second situation also where your application state is very complex. Then you can create multiple substates also. So in that condition, some other variable can exist in your app state that is again a complete substate also. So in that way you can manage a complex state of your application. But in our application we are having simple 3 attributes. 2 are related with the current location and another one is related with the weather data for that particular location. That's why we are having a very simple state, that is app state. So this is the hero of our movie, that is store class. And now you can see at the top we are importing that second Cocoa pod, that is ReSwift Thunk. So first of all, I hope you all remember that when we were explaining that Thunk component in the code structure. So Thunk is basically the place in the Redux architecture where you can write all your async code. And this is a kind of standard practice in the Redux architecture, that whenever you need to write async code that is majorly dedicated to the fetching of the data, then it must be written inside the Thunk only. It is a kind of pattern also in the Redux architecture that all the async code should be written inside the Thunk only. So that was the, you can say, brief overview of the Thunk layer. Now we will come to the line number 12, that is Thunk Middleware. The major contribution of the Thunk Middleware is in the Redux architecture is just to establish the communication between store and the Thunk layer. So whenever inside the Thunk layer you are writing your async code, that is majorly the API calling, that is giving you the data, then they must communicate back to the store in the Redux architecture. So that communication is established with the help of Thunk Middleware. And at the line number 15, you can see that when we are creating our app store with the help of store data type, then we are passing this middleware. So Thunk Middleware is the communication channel that establish the communication between your application store and the Thunk layer. And here you can see that this store data type is coming from your ReSwift framework. And similarly other reducer and some other data types also will be coming from this ReSwift framework. So now you understand what exactly the Thunk is. And the implementation of Thunk we will see later when we will explain this Thunk layer. And with the help of ReSwift Thunk, we are creating this Thunk middleware. And when we are creating our store object, that is app store, we are passing this Thunk middleware as the parameter. There are 2 other parameters also. One is application state, that is basically the default state of your application from where your application is getting started. And there is one more thing, that is app reducer, that we will explain later. But for now you can keep your focus only on the store object, that is app store. And this store is accessed, or you can say implemented as the global store, so that it is easily available to all the other layers of the Redux architecture. So this was the explanation of the store class. Now we will move to the action. So action is the class in the Redux architecture where you defined all the actions of your application. So what does it mean? Here you need to pay a little bit attention. So in our application, because there is no user interaction and we are fetching the weather on the basis of the current location of the user, so all the actions are self-initiated. But in your application there could be a possibility that there are some button press also, then ultimately again they will also be action. So the thing is, whatever action your application is having, you can define into the action class. So in our application we are having 2 implicit actions. One is get user location and another one is fetch weather for. So action is always implemented with the help of enum. We are naming it as the app action and inheriting it with the help of action class that is available from the ReSwift. And we are defining 2 cases in our application. One is getting the user location and second is fetching the weather for that current location. So these are the 2 actions that our application is having. So this was the very simple implementation of the action class. Next very important class is reducer. So reducers in Redux architecture are implemented with the help of function. So here you can see that we have created a function app reducer that is taking 2 parameters. One is of type action and another one is of type app state. So basically this is the action corresponding to the user interaction or maybe any implicit action in your application. and this state is basically the current state of your application. And on the basis of these two parameters, reducer will be able to calculate the new state for your application. And if you remember, we implemented that action thing with the help of enum. So on the basis of that enum, what we are doing here is reducer is basically updating or giving you the new state that is getting received from the Thunk. And how it is happening, we will discuss later when we will discuss that Thunk's implementation. For now, you can just understand that whenever an appropriate action according to the user interaction coming to the reducer for the app state change, then according to that action, reducer will update the state of your application. So here we are receiving the weather. So in this weather data attribute of the current state, we are updating this weather response. And similarly, when we receive the user location, then in the latitude and the longitude attribute of the current state of your application, we are updating new values. So the main job of reducer is to basically mutate the current state of your application, and this is the only place where exactly your state change happens according to the request or according to the interaction taken by the user. So this was the implementation of your app reducer. Next thing that we are going to implement in this particular sample is Thunk. So I have already told you that in the REDUX architecture, whenever you need to write asynchronous logic, then Thunk is the only place for that. This is basically the standard practice whenever you need to write asynchronous logic, for example, the API calling or any location fetching data or any other asynchronous logic, then you will always be writing into it the Thunk layer only. So in our application, majorly we are having two asynchronous things. One is fetching the user location or the fetching of current location of the user, and second, fetching the weather data according to the current location of the user. So let's take a look into the implementation of these thunks. So first thunk is fetch weather thunk, where exactly what we are doing is with the help of get state, we are receiving this current state of our application and getting the latitude and the longitude, that is the current location of the user, and giving it to the network manager for fetching the weather data. And once we receive the weather object, we are calling the appropriate app action. And here that app action is fetch weather for and giving weather object to it. Now you would be very surprised to know that whenever we are triggering this fetch weather for action, it automatically reaches to the reducer for the state change, because this function is nowhere implemented in the REDUX architecture. We just provided the appropriate enum, but with the help of that Thunk middleware, it is able to communicate with a store, and then store is able to communicate with the respective reducer, and with the inside the reducer body, it is reaching to the most appropriate place. So inside the reducer, you have already seen that there was a enum logic implemented on the basis of different actions. So that is the capability of Thunk middleware. And now you would be able to understand that how exactly, without any delegate, without any closer, without any notification, we are able to communicate from action to reducer, keeping store in the middle. So that is the capability that is given by the Thunk middleware. Now you would be thinking of that at the line number 13 and at the line number 14, from where this latitude and longitude is coming. So for that, we are having our first Thunk. Sorry, in the logical order it should be described at the first place, but there is a reason why I described this thing first and this thing as second. You will come to know. So for now, I am not jumping into the implementation of location manager. So what I am assuming is, with the help of location manager, I am receiving latitude and the longitude of the current location of the user, and once I am receiving that, then with the help of appropriate app action, that is get user location, I am updating the current application state. Till this particular point, we were setting the stage for the REDUX architecture, and now this is the place where exactly all the actors will interact with each other. So we will discuss our view controller implementation line by line. So at the line number 13, the very first point that you need to pay attention is store subscriber protocol. So when your view controller will subscribe to this store or will confirm this store subscriber protocol, then you would be, or you need to implement this new state function. And the objective of this new state function is to notify your view controller every time whenever your application state changes. So if you remember, in your app state you are having three parameters or three attributes. One is the weather data, second is location, and third is the second is the location itself. So here you can see whenever weather data is getting changed, or whenever your location is getting changed in the form of latitude and the longitude, then you are getting notified in your view controller. We will come to this later, but first we will understand the view did load of our view controller. So in the view did load, there is a function at the line number 21, that is setup UI, that is doing nothing, that is just setting your table view for getting and displaying the data. So here you can see, with the help of RX Cocoa, I am binding my table view. So at the line number 58, this setup UI is implemented. Now coming back to the view did load again, line number 24 is the important thing. So here we are subscribing to store with the help of this subscribe method. What we are doing here is we are making our view controller as the subscriber of the application store. So that means whenever there is any change in our application store, our view controller will be notified with the help of this subscription. Now next thing is, we will come to this point later, but logically we need to understand the line number 32 first, that when we are subscribing the store, then there is also a need of unsubscribing the store also. So at the view will disappear, we will unsubscribe to our store also, right? Because when our view controller is not in picture, then there is no need to have that observation on the store, because that view controller is not getting displayed to user anymore. Now come to line number 27. So at the 27, what we are doing is, the very first thing we need to do in our application is to fetch the user location. Now here you need to pay a little bit attention. So as we are not having any direct action related to the user interaction, that may come from any button press, but the thing we need to do is to fetch the user location. So what we will do here is, from the app store we will dispatch get user location thunk, and later on this thunk will be calling to the appropriate action, and with the help of Thunk Middleware, that action will be reaching to the store automatically, as we have already discussed, and then ultimately it will reach to the reducer and will be able to update the latitude and the longitude in your application state. And now what will happen exactly, when at the moment when your latitude and the longitude are getting updated in the application state, then exactly this new state function will fire. So first thing we need to do is to dispatch this get user location thunk, and when this location thunk will give you the latitude and the longitude in your application, then the control will reach automatically to this line number 53. In the line 53, what we are doing is we are receiving latitude and the longitude, not exactly, but we are getting the information basically that yes, the application state has been changed, and now we need to dispatch another thing, that is get user weather data according to its current location. So you already know that what is exactly happening in the fetch weather thunk. This will basically provide you the weather data on the basis of the user's current location. So this is the implementation of basically new state. And in the second part, when this fetch weather thunk will give you the weather data, then what we are doing is we are basically checking the success and the failure of that particular result type, and according to that we are just binding our UI table view with the help of RX Cocoa. This is the only UI binding logic we have implemented here that you can implement very easily. So that was the overall implementation of the new state function. Now what I will do, I will scroll this view controller implementation from top to bottom so that you can have a complete look that how exactly it is implemented, and I will try to describe the things very quickly and on the high level also for your understanding. So this is the UI table view outlet, this is your dispose bag, this is view did load, and here we are subscribing to App Store, we are dispatching the get user location thunk, and once we receive the user location, then that new state function will fire and the view will disappear. You need to unsubscribe the store from the view controller, and in the new state we have implemented that when we will receive the weather data or when the weather data state will change, we will basically update our table view, and when we will have the state change for the latitude and the longitude, then we will dispatch our fetch weather Thunk, right? So setup UI is nothing that just setting up your table view for getting and fetching the data, not fetching, only getting the data. And in the extension of the view controller there is just a delegate to set the height of your table view. So that was the overall implementation of your view controller. So now you know how state is implemented, store is implemented, action, reducer, thunks, and your view controller also. Now it's time to run your application. So when you will run your application, that will give you the weather data on the basis of the current location of the user. And this is the magic of Redux architecture, that you need not to fall into those trap of implementing multiple delegates, closures, and the notification. You are simply fetching the data on the basis of current user location with the help of Thunk Middleware and the ReSwift framework. So now you have your application up and running with the Redux architecture. So this is the correct time to jump into the interview questions. On the screen you can see some of the normal questions related with the Redux architecture. It's well and good if you are able to find the answer of these queries on internet, but if you are not, then always feel free to write me on my email ID, that is venugopaltewari@gmail.com. I will be more than happy to reply all of your queries. So this was the end of Redux architecture session. Soon I will be coming up with more interesting topics. Till then, stay motivated, keep learning, and goodbye for now.